Our tire is flat.
Are you serious?
Let's pull it over first.
Okay.
Oosh! It's completely flat.
It's okay. I will check for a spare tire and hydraulic jack.
Hydraulic jack? For what?
To lift the car.
I wonder how it can lift this big car.
Did you ever heard about Pascal principle?
No?
Hi everyone, I'm Ikmal and welcome to today's lessons. So based on the scene you saw earlier, do you wonder how hydraulic jack can lift a car? So today, come here, we're going to dive deep into the world of Pascal principle and its applications. But before we proceed, let me state the learning objective of these lessons, which by the end of our class today, you should be able to effectively communicate about application of Pascal principle in real world. So, in general, we will explore the core principle of Pascal and use in hydraulic systems, brakes, and lifts. So let's get started. To begin with, let's grasp the essence of Pascal principle first. At its core, Pascal principle is a fundamental concept in fluid mechanics that states when pressure is applied to an enclosed system or fluid, that pressure is transmitted undiminished to all portions of the fluid. So this phenomenon occurs because fluids do not have fixed shape and they can easily transmit force throughout their entire volume. Apart from that, it is important to understand that this principle hinges on the idea of pressure distribution within fluids. So when you apply pressure to a fluid within a confined system, such as hydraulic cylinder, that pressure is exerted equally in all directions. So it means that any force applied to the fluid is transmitted undiminished through the entire fluid. So this concept has profound implications in various real-world applications. Now, to make you understand better, let's dive into the formula that underpins Pascal principle. So Pascal principle states that pressure is equal to F over A, which is force over area. So this formula is a cornerstone of understanding Pascal principle. It states that the ratio of the force applied to the area over which it is applied is constant in a closed fluid systems. So in simpler terms, increasing the area over which force is applied results in an increase in the force on the other side. Alright class, I hope you understand how the formula of Pascal works, and we will do more exercises regarding the topic. But now, let's explore the practical application of Pascal principle where the magic truly happens. Let's talk about hydraulic system first. Hydraulic system use Pascal principle to transmit and multiply force through an incompressible fluid, typically oil or water, in a closed system. When you apply force to a small piston, that force is transmitted through the fluid to a larger piston. As a result, the larger piston moves, exerting a much greater force. So please remember, the key concept here is that the pressure applied at one point in the fluid is transmitted undiminished to all other points. So hydraulic systems are employed in various industrial and everyday applications. Here are some examples. Firstly, car lift. Pascal principles are used in automotive repair shops to raise vehicles for maintenance and repairs. A small force applied to a lever is transmitted through hydraulic fluid, lifting the car effortlessly. Secondly, construction equipment. Heavy machinery like cranes, bulldozers, and excavators use hydraulic systems to perform tasks that require immense force and precision. As you can see in the video, This is the DIY bulldozer that we can create by using Pascal principle. It looks fun and interesting, right? Maybe we can do it in the next class. So please, don't skip my class. Alright, we move on to the hydraulic brake. Hydraulic brakes in vehicle utilize Pascal principle to efficiently and uniformly transmit force to the brake pads, ultimately slowing down or stopping the vehicles. When you press the brake pedal, you apply force to a small piston in the master cylinder. So this force is then transmitted through brake fluid to the piston in the brake calipers, which are fitted with brake pads. The brake pads are pressed against the brake rotors, generating friction and slowing down the vehicle. So hydraulic brakes are widely used in automotive industry, providing safe and reliable stopping power for various vehicles including cars, trucks, and motorcycles. Now, we have come to the last application, which is hydraulic lift. So hydraulic lift are systems that use Pascal principle to move people or heavy objects vertically. So this lift consists of two interconnected pistons, a smaller piston, the one you apply force to, and a larger piston, the one that moves the load. When you exert a force on a smaller piston, it generates pressure within the hydraulic fluid. So this pressure is transmitted undiminished to the larger pistons, resulting in vertical movement. So hydraulic lifts have numerous applications in various industries, such as elevators. So hydraulic lifts are used in elevators to transport people or goods between different floors in buildings. So when you press the elevator button, you initiate the hydraulic system which moves the elevator car up or down. Number 2, maintenance lift. Mechanics and technicians use hydraulic lift to access elevated areas for repairs and maintenance tasks, such as working on aircraft or changing light bulbs in high ceiling. Alright, when we talk about elevators, and in fact, we are actually trying to identify application of Pascal principle in everyday life, have you ever thought about the elevator in college? In your opinion, does the lift at your I10 Puncak Alam College use hydraulic or not? Well, the answer is no. Let me explain. Basically, lift consists of two types, which are hydraulic lift and traction lift. So what is the comparison between these two types? In terms of operating mechanism, traction lifts are typically powered by an electric motor that use steel ropes or belts to move the elevator up and down. So they rely on friction between the ropes and the drive shaft to lift the elevator, while hydraulic lift use a hydraulic pump to push hydraulic fluid into a cylinder, which in turn raises the elevator car. Other than that, in terms of speed, traction lifts are generally faster and can achieve higher speeds compared to hydraulic lift, while hydraulic lifts are typically slower and better suited for low to mid-rise buildings. So by the comparison, you may know why we use traction lift instead of hydraulic lift, because if you use hydraulic lift, we may have the longest queue in the world. I'm just kidding, sorry. So I've done explaining a few applications of Pascal principle, and to sum up, these practical application of hydraulic systems, brakes, and lift show the power and the versatility of Pascal principle in various aspects of our daily life. So understanding how pressure is transmitted through fluids plays a crucial role in the reliability and efficiency of these systems. Alright class, before we end our class today, let's recap what we have learned. So first and foremost, Pascal principle is all about transmitting pressure undiminished in enclosed fluids. So Pascal principle applied in hydraulic system, brakes, lift, and countless other everyday and industrial applications. Then the formula of pressure, which is P is equal to F over A. So this formula helps us understand how force is transmitted in these systems. So we have covered quite a bit of ground today, and I hope this lesson has helped you appreciate the wonder of Pascal principle. So the moral of the day is think of our world as a closed box and the challenge we face as the pressure inside. So Pascal principle teach us that this pressure affects everyone equally, just like how life challenge affect all of us. Now, in the world of faith, we are equal in the eyes of God, just as Pascal principle shows equality in pressure. But what makes us different is our personal belief and how we live our life. So remember, while life treats us all the same, it's our faith and good deeds that make each of us a better Muslims. So that's all for today. See you in the next class. Khalas.
Wow, it's working.
Yeah, thanks to Pascal principle.
But Gemma, I don't think we have tires.
I can fly the sky. Never gonna stay.